Yes, so welcome back to this channel. Here, meaningful learning takes place. So we continue our discussion on permutation and combination. We've defined this concept over and over again. So, but this particular class is dedicated to combinations because we've used two classes literally to talk about permutation. Started from factorials, moved into permutation like properly, and now combination that should finalize the whole thing at this given time. So, as usual, try to make class as elaborate as possible, covering different aspects of the topic so I can learn once and for all instead of you looking for multiple videos to teach you different aspects of the topic. So yeah, combination refers to the possible arrangements, of events in such a way that the order of the events are not important. So possible arrangements of events in such a way that the order of the events are not important. Okay, or are not put into consideration. And then remember the letters, the stuff that we'll be using since ABC, right? So if you are to rearrange ABC, so what are the different kind of arrangement that you're going to have? We've been able to establish that we're going to have six, right? So AB, AC, BA, BC, CA, CB. 1, 2, 3, 4, 5, 6. But combination, as long as, what am I even doing? ABC, um, ACB, BAC, BCA, CAB, CBA. So yeah, these are the six different arrangements that you can have if the others are important. So if A coming before B is meaningful, and if B came before A, right? But for combination, as long as all these letters are the same, so it's A, B, C that are just changing their positions. So the order is not important. So combination is just one. So the combination will just be one way. And how many ways can you find the possible combinations of A, B, and C? It's just one way. Or in how many ways can you in what are the possible arrangement of three that I can get of three? So in how many ways can three letters be arranged in three ways? Oh, what am I even saying? So um in how many ways can you get three letters from three letters, for example? So it's one now. So the combination is one. Do you understand? How many ways can get three letters from three letters? It's just one. But if it was permutation, to be altering their direction, their order, and then counting them as different things. So let's now look at a general formula. I would say this is going to give us just one combination of it. So what formula can be then used to deal with combination? So n combination r is simply equal to n factorial divided by r factorial into brackets n minus r factorial. So if I have a question that says in how many ways can ABC be arranged if the order is not important? In how many ways can ABC be arranged? Like three letters be arranged if the order is not important. So what we are going to do is three. This is going to be three combination three. Right? It gives us three factorial over what's r 3 factorial into bracket 3 minus 3 factorial. I suppose you are using all the letters. And this is going to be 3 factorial over 3 factorial. Actually, 3 minus 3 is 0. 0 factorial is 1 in case you don't know. So we are going to be having this cancelling this cancelling this. So we are going to 1 over 0 factorial, which is 1 over 1, and then the answer is 1. So this is just the formula that we use for combination. As long as you are using all the letters as of or all I don't even know how to read it like this now. As long as you're not using a pass, like you're not trying to get a pass from a whole, the combination is one. Do you understand? But what if the question had been that in how many ways can two letters be obtained from ABC? Right? In how many ways can two letters be obtained from ABC? So what would be the different arrangement of two letters from ABC? So what exactly is going to be the combination of any of the two letters? Like maybe AC, you know, if you have A, B, C, for us to be able to get different order, so we could have A, B, no, we are looking for two letters, right? So we could have A, B is one letter. We can't say B, A because in combination, both of them are the same. So this is gone, right? Then AC is a different one, right? Then we are done with A. Then BC is a different one because we can't write BA. BA is already this. So BC is a different one. And we can't also write CB. Can't, because CB is same as this as far as combination is concerned, and we can't write CA because we already have AC. So we're expecting to be having like three ways, right? So let's then see if this goes with our, what do you call it, our formulas. This is going to be 3 combination 2, which is 3 factorial divided by 2 factorial divided by 3 minus 2 factorial. So this guy is going to be 3 factorial, 3 times 2 factorial divided by 2 factorial and times 1 factorial, because 3 minus 2. So this will cancel this, and then we are going to be having 3 ways. So you can see how the formula works. So it's important to like understand how the formula works before you now begin to like solve and solve and solve, because this guy doesn't care about all that. Okay. So yeah, that's that. And let's now begin to like solve like serious questions. So let's look at number another example. Find the number of ways in which a team of 11 players. This is one. Number of ways in which a team of 11 players can be gotten from or can be selected from a team of 11 players. So the total is from 14 players rather. We have a total of 14 players. So you want to find how many different ways you can get 11 players from 14 players. Alright, so the first one is okay, that's the first part. So we look at other parts. So here, if it was in how many ways can 14 players be gotten from 14 players, it's going to be 1 as far as combination is concerned. Because whether you choose Messi, Ronaldo, Neymar, blah 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 like that, or you choose Neymar, Ronaldo, Messi, everything is the same set of letters, right? The same thing, the same set of players, right? The rearrangement doesn't concern combination, so it's just going to be 1. So but in the areas where you're going to be having different answers, would then be okay. You're like selecting a subset from an entire set. So there are different ways you can do that. So for the first set, there are 3 players that you wouldn't pick, right? And then next set, 3 players that you didn't pick the other time, you could pick them now. Next set, 2 players that you picked in the first set, you can drop them. So different things like that. So just apply the formula straight. No need to like bother ourselves. So we're having 14 combination 11, which is 14 factorial divided by 11 factorial, then 14 minus 3 factorial. So in other words, you have 14 factorial divided by 11 factorial, and 14 minus 11 rather, 11 factorials, and then 3 factorial. So you will see that at the end of the day, 11 plus 3 will give you 14. Like that's just the way it works. What's 3 plus 3 will give you 3 at the end of the day. So you can easily say this is 14 times 13 times 12 times 11 factorial, 11 factorial divided by 11 factorial times 6. Like 3 times 2 times 1 is 6, right? So this guy can take this guy out. 6 here 1, 6 here 2. So you have 14 multiplied by 26, and that's going to give us 286 ways. 26 multiplied by 13 times 2 is 26. 14. 4 times 6, 24. 4 times 3 is 8, 10, then 26. So 364 actually. Why can I write 286? Okay, no. 364, that's a different question. So we have equals 364 ways. 364 ways. Now the second question here is so also find how many of this when the captain is included and not included. So if the captain is included, which means that one of these 14 players is the captain. Like the captain is just one person, that is his office. So if the captain is included, right? You already have the captain, which is 1, right? So you now have to select 10 other players. Do you understand? You've already selected the captain. Yes, one of the 14 players is the captain. You've selected him. The captain is definitely going to be there. So who are the 10 other players that are going to join him? So the way we solve that is that for the captain is 1 combination 1. Like there can be more than 1 captain, right? In a football team. So it's 1 combination 1, a special guy, right? Then multiply by, since if you remove a captain from the 14 players, you're going to be left with 13 players. So of those 13 players, you must now pick 10. What would you notice? 1 plus 10 here is 11. 1 plus 13 here is equal to your 14 back. 14 entire players, then you have to select 11 from them. The issue is just that you've picked captain, so no matter the team of 10 people that you now pick, the captain is there. and the captain is just one person. So that's how it's do this equation like this. So this is going to one combination. One is going to give us 1 now, right? So we have 1 multiplied by 13 factorials divided by 3 factorials, 10 factorials, 3 factorials times 10 factorials. Please put 10 times in your own work. You understand this now. So no need to be writing the formula and everything again. So we have 13 multiplied by 12 multiplied by 11 multiplied by 10 factorials, then divided by 10 factorials times 3 factorials. 10 cancel 10, 3 here 1, 3 here 2. 3 factorial is 6, so here 2. So you have 26, 30 times 6, 26 multiplied by 11. So 26 multiplied by 11, 26, 26. We have 286 ways. So this is going to be equal to 286 ways. So are you getting it? Are you feeling it? It's not. Let's keep enjoying yourself. Now, number 3, it says that if the captain is not included, so you remove the captain, he's definitely not playing. And captain is one of the 14 players, and he's not playing. So if you remove him, there are 13 players left. Out of these 13 players, you must now pick your team of 11 people. Like, do you see the way the logic is going? There's a captain, you are maybe suspended or something, right? Or maybe he's not around, maybe he's injured. So the captain is not there. So you have 13 players left. So the third one, if the captain is not included, so we are going to be having 13 players left, combination what? 11. We have to pick 11 from 13. And then this gives us 13 factorial divided by 11 factorial to factorial, right? So when we continue, 13 times 12 times 11 factorial divided by 11 factorial times 2 factorial. So this takes this out. 2 factorial is 2, 2 here 1, 2 here 6. So 13 multiplied by 6 looking like a 78 to me. So that's going to be 78 ways. So the captain is not there. 78 ways. Hope you're getting it, right? So keep chilling, keep enjoying yourself. Now, a different example. So I want to move into another vibe now. So out of 7 women and 9 men, this example 1, 2, right? So example 3. Example 3. So you have 7 women and 9 men. 7 women and 9 men. So out of 7 men and 9 men, right? Where is it? A committee of 3 women and 4 men is to be formed. So this is total, right? So a committee of 3 women. A committee of 3 women and 4 men. 3 women and 4 men is to be formed. Okay. So in how many ways can this be done? If any woman and any man may be included, any woman and any man may be included. In how many ways can this be done? If any woman and any man may be included. So there's no specialty. So just normal thing. How do we do it? You have 7 women. You want to pick 3 women. So 7 combination 3 multiplied by. You have 9 men. You want to pick 4 of them. 9 combination 4. So here we are going to be having 7 factorial over 3 factorial, 4 factorial, then multiply by 9 factorial over 4 factorial, 5 factorial. You should be used to this by now. So 7 times 6 times 5 times 4 factorial divided by 3 times 6 times 4 factorial. This takes this, 6 takes this. So we have 35 left on this side. Then, okay, let me just separate them. Then multiplied by, so 9 times 7 times 6 times 5 factorial divided by 4 factorial times 5. This takes this. So what's 4 factorial really? 4 times 3, 12, 12 times 2, 24. Right? So anyway, let's continue. So we are going to be having 7 multiplied by 5, which is 35, times 9 times 7 times 6. 9 times 7 times 6 over 24. That's 4 times 3, 12, 24. So 6 here 1, 6 here 4, why is this looking like a decimal? Oh, okay. So this is meant to be 9 times 7. Okay, 9 times 7 times 8. It's meant to be 8 there. Right, so I was wondering like what's going on. 8 times 8 is also there. Times 8 is there. 6. So 6 here 1, 6 here 4, 4 here 1, 4 here 2. So you can't get a decimal for real. So 35 multiplied by 9 times 7, 63. 63 multiplied by 2, that's 126. Alright, so 35 times 126 is going to give us 4, 4, 10 ways. 4, 4, 10 ways. The second question says, if one particular man must be on the committee, so that is the chairman, right? Maybe it's the chairman or something like that. So this man is unique. He must, whatever the arrangement that you guys do, that man must be there. So, alright, guys, whatever arrangement that you do, a particular man must be there. Do you understand? So that means that man is already out. Like, so you have a 1 combination 1. So you just have to go and look for the remaining people that will form the committee. Look at it. You need to, out of this committee, you need 3 plus 4. So you need 7 people, actually, right? So you pick one particular man. So that means you need 6 people now. But where did you pick that man from? That man was picking from 9 men. Yeah, and then you must have 4 men. So which means that now you must pick 3 men out of the remaining 8 men. So we can still have 4 men back. Okay, so that's going to be this times you have 8 men left, you've taken that man, then combination. You need 3 more to get 4 men for this committee. Then it doesn't affect the women at all. For the women, you still have 7 combination 3. 7 combination 3. So 1 plus 3 plus 3 is 7. So still give you your total number of people back. 1 plus 8, 9, 9 plus 7, 16 to give you your 16 back. So how do we solve this? So this is 1 multiplied by its factorial, 5 factorial times 3 factorial, and multiplied by 7 factorial, 4 factorial times 3 factorial. So 1 times whatever, so 8 times 7 times 6 times 5 factorial divided by 5 factorial times 6. This cancels this. Okay, 6 cancels this. 5 times 3 factorial, to be honest, is actually 6 factorial. So if you think of it, 5 factorial multiplied by 3 times 2 is 6. So 6 multiplied by 5 factorial gives us 6 factorial. So I could have just stopped at 8 times 7 times 6 factorial over 6 factorial. You get what I mean? So I would add just 8 times 7. Now we come to this side. 4 times 3 factorial. This is not same as 5 factorial. 7 factorial, 7 times 6 times 5 times 4 factorial divided by 4 factorial times 6 as well. This takes this guy out. This takes this guy out. So I'm going to be having 63 multiplied by 35. So 63, 35, 15, 30, 31, 9, 18, 5, 0, 2, 2. 2205. Wow. Was that what I got? No. 8 times 7, sorry, is 56. 8 times 7 is 56. So this is 30. 5 times 3 is 25, 28. Okay, so I'm sometimes make mistakes. We have to be as careful as we can be. 3 times 6 is 18, 15, 16. So 0, 6, 9, 1. So this is equal to 1960 ways. 1960 ways. Alright, so what if you add that? What would be the probability that one particular man is included in, like, on this committee? Probability that one particular man is included on this committee. What would you do to that? Maybe we can think about that, guys. Alright, maybe we can think about that. But for real though, it's going to, this is the number of ways that you're going to have for one particular man being on that committee. And then you know that it's going to be this over the total sample space. Do you understand? Over like picking 7 people from 16 people, to be honest. So whether they are men or women or whatever. So let's just add that. Probability of one particular man, of one particular man on the committee. Okay, so total sample space, that's not going to care about men or women. Total sample space, so actually equals 16 combination, you must pick 7 people out of it. So and then so this guy, probability of this person, probability would then be equal to 1960 ways over the total number of ways that you are going to have 16 combination 7. So if you do 16 combination 7, 16 factorial over 7 factorial 9 factorial. So this guy is going to stop at 16 times 15 times 14 times 13 times, oh wow, this is a lot, times 12 times 11 times 10 times 9 factorial, then everything divided by 7 factorial times 9 factorial. So this takes this out. Right, so let me just finish it here. So 16 times 15, 15 times 15 times 14. What's most of comes to 9? Times 13 times 12 times 11 times 10 divided by 7 times 6 times 7 times, yeah, 5 times 4 times 3 times 2 times 1. Oh my god, this is a lot of things. Okay, so 7 can go here, 7 here 1, 7 here 2. Alright, these 2 can cancel this 2 that is here. 4 times 3 is 12, so 4 times 3 here 1, 4 times 3 here 1. So you have 6 and 5 left. 5 here 1, 5 in 10 is 2, 2 in 10 is 1, 2 in 6 is 3, 3 here 1, 3 here 5. So if you destroy the denominator, so you have 16 times 5, which is 80. 80 times 13, 80 times 13 times 11. Okay, yeah. So 80 times 13 times 11. So at the end of the day, we are going to be having equals 1960 over 80 times 13 times 11. So obviously this denominator is much more than the numerator. So when you finish it, just use your calculator to finish the whole thing. We are going to be getting 0.17. So 1960 divided by 11,440. 1960 divided by 11 yes, it's 11,440. The probability is going to be 0.17. Just calculate it to be sure. Well, this is how you're going to do it anyways. 0.17. So don't be surprised if you find a probability question in a permutation and combination question. So it's still still chill, right? So we are going to the last part of this topic now. Looking at something similar to the thing that we did in the last part of the permutation class. The last thing we have to do now is what we call symmetry. Just talking about equality of some qualities that you can find in combination, outstanding combination. So the first one is we have NCR. NCR is same as NC n minus R. Okay, so the explanation behind this is that the combination of picking something out of something is a combination of not picking something out of it. Okay, so the combination of like the arrangement, the combination of picking 5 out of 11 is a combination of not picking 5, like should be equal to combination of picking 6. And so we have this thing called symmetry in combination, just talking about equalities. So where NCR is same as n minus r. So for example, the combination of like the possible combination of picking 11 players out of 14 players should be equal to the combination of not picking 3 players. Combination of picking 11 out of 14 players. The combination of not picking 3 players out of 11 players. Do you understand? So the combination of picking 11 players out of 14 players, the combination of not picking 3 players out of 14 players. So like that's like the logic behind something like this. Okay. Then so n combination 11 is same as n combination 4. So they should be the same thing. And the second one, if you want to test this though, let's say 15 combination 11. Um, or 14, like the example that we did, this is going to be equal to 14 factorials into brackets 11 factorials times 3 factorials, right? And look at 14 combination 3. Combination, like the possibility of not picking 3 players out of 14 players. It's still going to be equal to 14 factorials over, this time 3 factorials comes first, then 11 factorial comes next. But it's not the same thing at the end of the day. So that is why, this stands. Do you understand? So sometimes if you have 9 combination 6, same as 9 combination 3. So in case you see something like that in the future. So number 2, don't worry, soon it's going to be over soon. N plus 1 combination R plus 1 is actually equal to N combination R um plus N combination R plus 1. So plus, yeah, plus. So N combination R, then plus, you still have your N, not N plus 1. So be careful. And yes, I want to like solve to illustrate this. Let's say assume that N equals 3 and R equals 1 and R equals 1. So look at this. This is going to be equal to 3 plus 1, Abi. So 3 plus 1 combination 1 plus 1. So is it going to be equal to 3 combination 1 plus 3 combination 1 plus 1? So that's what like that figure out. So this is going to be 4 combination 2. Is it equal to 3 combination 1 plus 3 combination 2? Now 4 combination 2 is literally 4 factorials over 2 factorials times 2 factorials. So is it equal to 3 factorials over 1 factorial times 2 factorial plus 3 factorial over over 2 factorials times 1 factorial. So 3 combination 2. Okay, so this is literally going to give us 3 factorials because 2 times 2 is 4. Well, for the sake of those that don't like maths, so 4 times 3 factorials, right? But 2 factorials is 2 times 1. Right, 2 times 1 times 2 times 1 is going to give us 4. So that's what I mean. This is cancel out this. And you have this is 3 um times 2 factorials over 2 factorials plus 3 times 2 factorials over 2 factorial. This takes this, this takes this. Now 3 factorial is 6. 3 times 2 times 1 is 6 equals, then you have 3 plus 3 here too. So you can use other set of numbers like prove it, to get what you're supposed to get. So I believe this kind of relationship would be necessary or be important in like future lessons. You just have to like recall a particular relationship that exists between two things. So yeah, with that, we've come to the end of combination at this particular period of time, except something comes up in the future. We'd like to update our lessons with more requirements. Okay. So let's look into our assignment now. Here's the assignment. Find the values of A, 10 combination 4, B, 6 combination 2 multiplied by 5 combination 3. Then number 2, a football team contains 3 defenders, 3 midfielders, and 5 forwards. For those who are familiar with football, so forwards includes your striker, your wingers, your center forward, things like that. But just leave it as forwards. Now, 3 players are chosen at random to collect a gold medal for the team. So finding how many ways this can be done if A, the captain, who is a midfielder, must be included with a defender and a forward player. So the captain, who is a midfielder, must be included with a defender and a forward player. And B, if exactly, like finding how many ways this can be done, if exactly one forward player must be included together with any 2 others. So if exactly one forward player must be included together with any 2 others. So in what ways would you would your would 3 players selected to get a good medal be, right? by the time you're done. So that's about that. Again, if you have questions, you can leave them in the comment section. And yeah, see you again. Bye.